Hello everyone, this is DSA Zindabad. Today we are going to solve the second question of Arsh Goyal DSA sheet. The question is sort colors. Let's see what the question says. Given an array of nums with n objects colored red, white or blue, sort them in place so that objects of the same color are adjacent with the colors in the order red, white and blue. We'll use the integer u0, 1 and 2 to represent color red, white and blue respectively. You must solve this problem without using the library's sort function, right? Now let's look at the example. We are given this array 2 0 2 1 1 0. Now after sorting, this will become 0 0 1 1 2 2. Now the second example is 2 0 1. Now after sorting, the array will become 0 1. Right. So our main goal is to sort the array, right? Now the basic approach, like now let's jump into the approach, right? First of all, let's discuss the brute force approach. Brute force approach. Brute force approach says just sort the array using merge sort, quick sort, or any of the sort. If we are using merge sort, then its time complexity would be big of n log n, and the space complexity would be big of n. Right. So this is not the optimized approach. So let's discuss the more better version of the approach. Second one is better approach, right? Now, what could be the better approach? We are given this array. Let's take this example. 2 0 2. Let me write this thing for you. 2 0 2 1 1 0, right? We are given this array. Now this is the index 0 1 2 3 4 5. So for the better approach, what you can do, first of all, we'll initialize 3 pointer, count 0, count 1, and count 2. And what this pointer are going to store, these pointers are going to store the count of 0, 1, and 2 respectively. Like, first of all, what we need to do, we need to traverse over this array and count the number of occurrences of 0, 1, and 2 and store all the occurrences in this pointer, right? Now, after traversing over this nums array, the value of count 0 will become 1 and 2, and the count of 1 will become 2, and the count of 2 will become also 2, right? Now, after this, what we are going to do, we need to run our loop from 0 to 1. And what we will do, we'll manually fill the entry from 0 to 1, because we know, like, initially first two places will be filled by 0, and the next place will be filled by 1, and the next place will be filled by 2. All right. So what we are going to do, we are running the loop from 0 to 1. Now we'll manually fill the array with 0. Now again we'll run the loop for the 1 element. Again 0 to 1 here. Again manually fill the array. Manually filling the array, like what I mean, overwriting the initial array, overwriting the input array. Right. Now same goes for the count to 0 to 1. Now again we are overwriting this, right? Now let's discuss the time and space complexity for this approach. First of all, what we are doing, we are just storing the count of 0, 1, and 2, right? So this will require big of n time, right? And when we are traversing over the array, like manually overwriting the array, then it will also require big of n time. Now ultimately our time complexity will become big of n. First of all, this is for storing the count of 0, 1, and 2 in the pointers count 0, count 1, and count 2 respectively, and big O of n for manually overwriting the array, right? Ultimately, this will become 2 of n. So this is a two-pass solution. What is it? It is a two-pass solution since we are iterating over the array 2 times, right? And the space complexity would be big O of 1. Since we are not using any extra space, we are just overwriting the our input array, right? No extra space. Now, can we do this problem in a like one pass? Yeah. Now, let's discuss how we are going to solve this in using one pass. And this is the optimized approach, right? One pass solution. So for this, what we are going to use an algorithm named Dutch National Flag algorithm. Dutch National Flag algorithm, right? So let's discuss what does Dutch National Flag algorithm says. It says it is a algorithm, three-way partitioning algorithm, three-way partitioning algorithm. It is an algorithm for sorting an array containing three distinct values, containing three distinct values. And in our problem, the problem also contains three distinct values, which is 0, 1, and 2, right? And this algorithm was designed to solve the problem of sorting an array containing only zeros, ones, and twos, which is similar to the problem in the given question, right? The algorithm works by maintaining three pointers, right? How it works? By maintaining three pointers name, low, mid, and high, right? And the how, let's discuss furthermore. Our low pointer will be pointing to the beginning of the array, and the high pointer will point to the end of the array, and the mid pointer starts at the beginning of the array and moves through it, right? Let's say this is our array. This is the random example which I'm taking 2, 2, 1, 0, 1, 0, right? Our low will be pointing to this, and our mid will also be pointing to this, and our high will be pointing to this, right? This is what this algorithm says. Now, let's discuss the idea behind this algorithm, right? Idea behind this algorithm, right? The idea behind this algorithm is to keep all zeros before the low point. Keep all zeros before the low pointer. What does it mean? Like, let's say our low is pointing to this, and all our zeros will be there before this low, right? Now, all the twos are after the high pointer. Let's say our high is there, high. All twos will be after the high, right? And all the ones lie between low and high pointers. The algorithm moves the mid pointer through the array, comparing the value at each position with 1. If the value is 0, the element is swapped with the element at the low pointer, and the low and the mid pointers are incremented, right? If the value is 2, the element is swapped with the element at the high pointer, and the high pointer is decremented. If the value is 1, the mid pointer is simply incremented. The algorithm terminates when the mid pointer crosses the high pointer, indicating that all the elements have been processed and the array is sorted, right? This is what this algorithm says. Now let's uh, make make this thing much more clearer, right? Let's write this from 0 till low minus 1 will have 0 on the extreme left, right? And from low till mid minus 1, right? Till mid minus 1 will have 1. Now from high plus 1, this is our high plus 1, right? high plus 1 till n minus 1. N here is the size of the array. This will be 2 on the extreme right. Now let's make this more visual. 0, 0, 0, 0, 0. This is our low minus 1, right? Now this will be our low. This will be our 1, 1, 1, 1. And this will be our mid minus 1, right? This is our mid. And this is our high. Remember guys, in between mid and high, there is unsorted array, right? There is unsorted array. Now after this, we have 2, 2, 2, right? This is our n minus 1 and this is our high plus 1, right? Now initially, as you can see, let's say this is our array, 2, 2, 1, 0, 1, 0, right? Initially, our low pointer and mid pointer will be pointing to this element, and this here we have high pointer, right? Now this algorithm says like between mid and high, between mid and high, the array is unsorted, right? As you can see, like this array is unsorted, right? Now we need to move our pointers, like we need to check whether we encountered a 0, 1, or 2, then we'll swap the elements accordingly. Let's see. Let's say we are moving our mid pointer. We can also do the same thing with the low pointer. But in this video, we are doing this thing with the mid pointer, right? We are taking the mid pointer for moving ahead. For moving ahead. So now, let's say this is our array, right? Let's say when we encountered a 0, what we are going to do? Let's say we are at this position, right? Our mid is at this position. When we encountered a 0, what we need to do, and our low pointer will be pointing to this, right? When we encountered a 0, we need to swap the element which is present over there at the low with the element at the mid. Because as we know, like this 0 will be there instead of there, right? Because all zeros are there at the extreme left and all twos are at the extreme right. So we need to swap the element at the low at the mid index. Now after this, what we need to do? We need to increment low as well as our mid, right? Because 0 occur at the extreme left. Now let's see when we have 1, what we need to do. Let's say we are mid as at this position, right? Then we just need to increment our mid pointer. Then increment mid plus plus, right? Now, when we encounter a 2, what we need to do? Since 2 is there on the extreme right, so we need to swap the element with mid, right? This is what we need to do. And we need to decrement our high pointer. Let's take one example for the same. Let's take this example. 2, 2, 1, 0, 1, 0, right? 2, 2, 1, 0, 1, again 0, right? This is what we have. Initially, our low pointer and mid pointer is pointing to this, and our high pointer is pointing to this, right? as we can see, we encountered a 2 over there. As we all know, 2 should be present there at the extreme right. So we need to swap this element with the A of mid with the A of high. So this element will be swapped with this element, right? So there we have 0 and there we'll have 2. And after this, we need to decrement our high pointer, right? Now, high pointer will be pointing to this, right? Now, after this, again we'll iterate, and again we found that at the A of mid, what we have 0. And when we encounter a 0, we need to swap the element at the index of low with mid, right? Swap this two element when there is a 0, right? Now, since low and mid point are both pointing to the same position, so we just need to increment both of them, low and mid. Now, after again we are encountering a 2 over there. Now we again need to swap these two positions, right? And we'll decrement our. Now again need to swap the positions. 1 over there, and over there we'll have 2. Now we need to decrement our high point. Now, as you can see, for like after high, we have 2 over there, right? 2 is over there, 2 is over there after high pointer, right? And before low pointer, we have 0, right? So this is what the algorithm says, like before low pointer will have zeros on the extreme left, and after high pointer will have 2 on the extreme right. And as you can see, between these two, like between mid and high, the array is unsorted, right? Now again, we are encountering a 1 over there. Now, since this is not an issue, so we just need to increment our mid plus plus. So our pointer will be pointing to this mid, and low pointer will stay the same, right? Now after this, we are encountering a 1 again. Now what we need to do? We need to again iterate over the array, and our mid will be pointing to this. Now at this time, we are encountering a 0. So when we encounter a 0, we need to swap the element with the pointer at low, right? We need to swap these two positions, right? Now 1 will be there and 0 will be there, right? Now we need to stop when mid and high cross each other. Now as you can see, like after this, our array becomes sorted. Now our array will look something like this: 0, 0, 1, 1, 2, 2, right? This is our sorted array. I hope this approach is clear to all of you guys. Now let's try to code this thing up. So we'll declare 3 pointers according to the Dutch national flag algorithm. Mid will be pointing to the initial start of the array, and our high will be pointing to the n minus 1, the at the end of the array, right? Now we'll iterate until mid is less than equal to high, right? Now, first of all, we need to check if we encounter a 0, we need to swap the elements at low and mid index, right? Now, after this, we need to increment our low as well as mid pointer. Else if we encounter 1, then we just need to increment our mid pointer, right? Else, when we encounter a 2, then we need to swap the elements at mid index and at high, right? Then again decrement the high. Now let's try to run this code. Now let's try to submit this code. This code is this code works perfectly fine, right? Now let's discuss the time and space complexity for the same. Since we are just iterating over the array, so it will require big O n time, right? And the space complexity would be big O of 1. Why we are requiring like big O of n time complexity for this? Because initially what we are doing, we are, let's say this is our array. What we are doing, we are just iterating over the array, and from there we are incrementing low and mid. From there we are also decrementing our high pointer according to the conditions. So it will require big O of n time for just iterating over the array, and this is a single pass solution. I hope this approach is clear to all of you guys. Thank you so much for viewing the video till the end. Please like, share, subscribe. Thank you so much.